So we're recording the session. So tonight's session is going to be the final exam review. So I'm going to go over some of the problems that I've selected. They're not from your final exam, but they are pretty close to what you're going to get. So I'm going to share my screen. So let me know if you can see my screen here. So if you can just tell me that you can see my screen. Okay, great. So I'll get started with the final exam review, and then if there are any questions, we can I can answer those at the end of the session. And generally, the way I do this review is because you've done all these questions, you have practiced them, and if you feel like you need more detailed sort of help, then I would have you access these recordings here. So note that all the webinar recordings are available on Professor David's website, as well as your courses in Blackboard. So they are posted in the course calendar that is included in the webinar information tab in your courses in Blackboard. The other way, obviously, is to get it through Professor David's website. All these recordings are available under 16EW1. So if you need extra, help with these problems, I would suggest that you access these recordings. Okay, so I'm gonna just put the link here as well so that you can access these recordings here. Okay, so here's the final exam review. Again, just to remind you, you are all given this final exam review document. Should be posted in your courses, and if it's not, please ask your instructor. Otherwise, it is also posted here on this website that I just shared. It's posted under 16EW5, and it's called List and Tips and the Review Problems. Review Problems is what we're going to go over tonight. List and Tips is this document, which tells you, the 28 problems that you're going to see on your exam. It doesn't give you the problems, but it does give you some tips and the type of the problem, as well as a homework reference problem that you've already solved. So this is a really good document, to prepare for the final exam. And you can also tie some of these review problems that we're going to go over tonight to these problems. So I would have you, I would like you to do that. Okay, so if you need more help with problem number 2 or something, well, see what problem number 2 is about, and then look for that problem here, and then obviously you've solved it because you have solved a reference problem, and then from here you know which recording you should access to get help on that problem. So these two documents are really good to prepare for the final. But anyway, let's get started. So here's the first problem where we have to compute some stats. So suppose we have this data. So this is the data set given to us, and we want to be able to compute the mean, median, mode, range, and the standard deviation. So, as well as the variance. So what I've done is I have already entered this data in StatCrunch. So here's the data for Q1. And what I would like you to do is tell me what do you think, how can we solve this problem? Just real quick, and then I'll show you how to do it. Yeah, so you go to just stat, and you're going to go to summary stats and columns. Yep. So you're going to go to, let me just do that again slowly. You're going to go to stat, summary stat, and columns, because that's where all your summary statistics are given. And I'm going to choose Q1 because that's where my data is located. And I'll choose all the stats that we were looking for. So we need the mean, median, mode, range, standard deviation, mean, median, mean, variance, standard deviation, median, range, and we need the mode. So the mode is at the bottom. And so you're going to choose all those, and you'll see that they will get highlighted here. Now note I was holding my control key as I was selecting these, okay? So in order to select more than one, hold the control key on your keyboard and then just keep clicking on the stats that you're looking for. Just hit compute. And there you go. Those are your statistics. Very simple, straightforward. There's nothing complicated in this problem. And then you see that there's no mode. And the reason is, why is there no mode? Exactly. The frequency of all these numbers is just one. There's no number that repeats itself for the frequency to be more than one so that it is the mode. Okay, so there is no mode in this problem. Excellent. Okay, simple. All right, how about this problem? And by the way, I want to point out in each of these problems that we're going to review, notice that I have given you directions on how to solve it in StatCrunch. Okay, so StatCrunch directions are given to you. So you can just follow these to solve this problem. And I've also given you the answers so that you can match the answers that you get, okay, with the correct answers. Okay. All right, so discrete and continuous variables. So tell me, are the following variables discrete or continuous? The time it takes to fly from city A to city B. Now, obviously the answer is given here. And the answer says the time, the first variable, this variable, time it takes to fly from city A to B is continuous. And the reason for that is because remember I had mentioned this in the webinar, week 1 webinar, that time cannot be counted. Anything that can be counted is discrete. Anything that has to be measured is continuous. Time cannot be counted. Time can be measured. Okay, so that's why it is continuous. However, the number of people in a restaurant that has a capacity of 200, right? The number of people you can count, and you can definitely count up to 200. So this is a discrete variable. And the reason is because again, you can count the number of the number of people in the restaurant. Okay, so that is how you differentiate between the two variables. Okay, there's nothing too complicated here either. Okay, now things are getting interesting and we are now doing a problem on normal distribution. Okay, so this was week 2. A random variable x is normally distributed with mean 50 and standard deviation 7. And we have to compute probability that that variable gets a value of 42 or higher. So if I were to draw a normal distribution curve, okay, so I'm going to draw a curve. And what we are looking for is mean is 50 and we're looking for a value 40. So mean is 50, so the mean is going to be in the center. So where would 42 be? On the left or the right side? On the left side, right? So 42 is going to be here somewhere. And we need probability that x is greater than 42. So which area am I going to highlight? Excellent. Area 42 or higher. Yes, so this area. Okay, so that is what I'm looking for. Now, why did I draw this? Can anyone answer why did I draw this diagram? Because I like to stress on something. Let's see who can remember. Yes, absolutely right. Okay, I drew this because so that you can verify your answer at the end. These problems, you can get them wrong very easily if you don't have this drawing in front of you. Okay, because they look very easy, but they're not very intuitive until you actually have the diagram in front of you. So this is the reason I drew it. Okay, so please make sure when you solve these problems, have the drawing in front of you. Okay, so now, so what is the area that I'm looking for is 42. So, okay, so how do we solve this problem? Okay, so you just saw the diagram and I'm going to compare it again. But let me show how we can do that. So the problem says go to stat, calculators, normal. Okay, so that's what I'm going to do. I'm going to go to stat, calculators, normal. okay? And then once you're here, it's so easy. The mean is given as 50. The standard deviation is given as 7. That's given in the problem. I'm looking for a value of 42 or higher, so I'm going to choose the greater sign. Okay, and then you'll notice that it highlights exactly the same region as you had anticipated, and the answer is given as 0.8735. So you can see that this matches the diagram that you drew, right? So that's the answer there. Very simple, nothing much to it. And so that is the answer, 0.8735. Okay, I think you'll find that my directions here will help you out significantly, right, in solving these problems. So please make sure to follow those. Okay, so here's the problem, central limit theorem. Again, as I said, I'm not going to go in the details of the conceptual detail because those are already recorded. So please make sure to view the recording for those details. But this is a very simple problem. You have a simple random sample of size n, and that is drawn from a large population with mean mu and standard deviation sigma. And the question is, what happens when you have a sampling distribution of the means? So again, I'm not going to go too much in the details, but if you recall, I had said that you have a large population, okay, where you have a mean mu and standard deviation sigma. And what you do is you don't know this mean and you don't know the sigma, but what you do is you take samples. This is the first sample, second sample, and you keep taking this many, many times. And each time you take a sample, you calculate its mean, the sample mean, which is x bar. So this is the sample mean for the first sample mean for the second sample, and you keep going for the third sample, oh, sorry, for the nth sample, however many samples you take. Say you take 1,000 samples. So this is the 1,000th mean. So these are all means of the samples. So remember I said when you take the mean of the means, which I'm going to call x bar, bar is the mean of the means, okay? Then this mean is going to be equal to this mean, okay? That is what central limit theorem says. So in other words, the answer to this question is that the mean of the sampling distribution of x bar is going to just simply be mu, okay? It's going to be equal to the population mean. Okay, that's what I showed. And then the sigma, the standard deviation of the sampling distribution, standard deviation here is not going to be exactly equal to sigma. It's actually going to be sigma over square root of n, okay, where n is your sample size, okay? So that's the difference here. And again, the conceptual detail is covered, I believe it was week 2. So you can see the detailed concepts on that, but this is the answer. It's a very simple question. And so here's the answer given. Okay, so this is regarding the central limit theorem. Okay, so now we go to question 5. Now, confidence interval for proportions. So this is where the fun starts. So we have to construct a 99% confidence interval of population proportion. Oh, I see there's a question. Is StatCrunch always available as an aid even when I'm not enrolled? Yes, it is, but I think your subscription is probably going to expire soon. I don't know how long it is, but you can access it later. Yes, I think they have a monthly subscription and it's not very expensive. It's not that expensive at all. But anyway, if you take any higher level stat courses, you might go into other software packages like Minitab or R, you know. So those are probably a little more industry level. But what you learned is pretty much how all these different packages work. Okay, anyway, so we have to construct this confidence interval. Now again, I'm going to remind you that I'm not going to go over the equations because again, they're covered in the recorded lectures. of how to do this manually. But here's how you do it in StackCrunch. So you have X is 120 and N is 200. So the population proportion is what you're trying to estimate, okay? The confidence interval of population proportion. So what you do is you take a sample of 200 and you find that out of the 200, 120 observations are of the interest. So what is the proportion of interest? The proportion of interest is 120 over 200, okay? And but that's not enough. You have to create a 99% confidence interval. So let me show you how to do that. Okay, let me just bring this here. So, okay, so the way you do that is you're gonna go to stat, proportion stats. Proportion stats is every time you want to do something with proportion, okay, you're gonna go to proportion stats and you only have one sample. You don't have two samples, just one sample, and you have the summarized data. So I'm gonna access with summary. And the rest is very simple. Number of successes, I said it's 120 out of 200. And I need a 99% confidence interval. So I'm going to put 99 here instead of 95 and hit compute. And there you go. That is your answer. We can match it with the answer. The lower limit is 0.5108 and the upper limit is 0.6892. Okay, and remember I like to call them the believable limits. Okay, confidence intervals have a lower and an upper limit, and they determine the range of values that are believable. So that outside, if you're outside of these, these limits, so say you're below the lower limit or above the upper limit, then those values are not very believable. Okay, so that's how I like to think of them. But very simple answer. Okay, now we'll go to question 6. Now 6 has data in it. Okay, so 6 has some data in it. So here's the data. This is raw data given to you. It's not summary data anymore. Okay, and I have entered that data here. So now we have to construct a 99% confidence interval, not for the proportion, but for the mean. So we need a 99% confidence interval for the population mean. Okay, and how do you do that? You take a sample, and then you're going to use the sample to create that confidence interval. Now, how do we do that? Well, remember I had said this was week 3 that whenever you are interested in the mean, okay, you're going to open the data just as I have been. The data will be given to you, so you're going to open it in StackCrunch just like you've been opening the data in your homework assignments. So all the data will be given to you in the problem. I entered this because I created these problems, so that's why I had to manually enter them. So the 99% confidence interval for the mean. So remember I had said that whenever you talk about the mean, you always think of the t distribution, okay? You always use the t distribution whenever you have the mean. So how do we do that? Now we're going to go to stat, and instead of going to z stats or proportion stats, okay, proportion is for proportions, I'm going to go to t stats, okay? For the mean, I will go to t stat. It's one sample, and I don't have the summary. I actually have the actual raw data. So I'm going to click on with data. Okay, now the data is in this column, whatever column it's in, Q6, and I need 99% confidence interval instead of the hypothesis test, so I just choose that. Okay, very simple, right? Straightforward, and I hit compute. And again, I get my lower and an upper limit for the mean now. So you notice these are not proportions anymore. It's not in decimal points where, um, like percentages. These are actual numbers because we're trying to estimate the mean. So the lower limit for the mean is 12.85 and the upper limit is 22.36. And again, this defines a range of believable values. outside of this range, the values cannot really be trusted. Okay. I selected Q6 because that's where my data is, right? This is question number 6. So, okay, so if there's some confusion here, what I did was before the webinar started, I populated the data for all the questions here because I didn't want to spend time populating these the data. And you won't have to do that because the problem will give you the ability to open the data in StatCrunch. Okay. The reason is I created these problems. I created this document, so I had to manually enter this data in StatCrunch. Okay. So yeah, this is the data. This is the same data that you see here in the problem. It's the same data here. Okay. All right. Now we go to hypothesis test. So hypothesis test for proportion. So we have to use the p-value approach to do this hypothesis. So we all know this is, this was in week 4 and week 5. The null hypothesis here says that the proportion is 20% or 0.2. The alternative says that is greater than 0.2. And here is the sample data. We sampled 200 items. We see that 45 of them are of interest to us. So 45 out of 200. And we have to carry out this hypothesis test. So again, it's the directions are given here in StatCrunch. But let me show you how to do that. So you're going to go to Stat, Proportion Stats, one sample, because you have one sample, and you don't have the data now, you have the summary. Okay, so I'm going to go to Summary. Now, everything is pretty much straightforward. Number of successes is 45. Number of observations total is 200. Okay, and then the hypothesis test for P, you have to change to match the problem. So the null is 0.2, so I'm going to change this to 0.2. The alternative says that P is greater than 0.2. I'm going to have to choose the greater sign here. Hit compute, get my answer. So Z is 0.88 and the P is 0.188. So what do you think, given this P value, what do you think is my conclusion? If say my alpha is 5%. Should I reject or not reject the null hypothesis? Okay, so I should not reject the null hypothesis. P is greater than alpha. If the P is high, the null must fly, right? So do not reject the null hypothesis. So alpha is 10%, and I'm getting 18.8%. Okay, so I will not reject the null hypothesis. Okay, so this was a very simple question here. Is NP naught 1 minus P naught greater than 10? Well, let's do that. So my N is 200. P naught is the P value, sorry, P naught is the proportion under the null hypothesis. So P naught, or P0 you can call it, is this P here, 20%. So it's 0.2. 1 minus P naught, P0, is 1 minus 0.2 or 0.8. So this becomes N times 0.2 times 0.8. Okay, so I'm going to do that here. So N is given as 200, sorry. So it's 200 times P0, which is 20%, times 1 minus P0, 1 minus 0.2, or 80% or 0.8. And that's my answer, 32. So is 32 greater than or equal to 10? Yes, it is. And if it is true that it's greater than 10, then we can carry out the hypothesis test. Okay. So yes, this is true. Yes, we are assuming that. Okay, and then we had to find the p-value. So the p-value is, okay, Vince. So basically all I did was I just took this equation, okay, n times p0 times 1 minus p0. N is 45, p0 is 20%, 1 minus p0 is just 1 minus 20%, okay, 100 minus 20%, which is 80% or 0.8. So this is simply just 200 times 0.2 times 0.8. And so if you do that, when you multiply those values, you get 32. And so the question is 32 greater than or equal to 10? So 32 is greater than 10. So yes, it is true. And if that is true, then I meet the requirement to carry out the hypothesis test. All right, now find the p-value. So the p-value is, so, okay, so here's what I'm doing. Okay, so it's just a very simple calculation. Okay, so I just took the equation, plugged in the values, and I get my values that I have to multiply. So now I do this in the calculator. 200 times 0.2 times 0.8, I get 32. And the question is 32 greater than or equal to 10? So yes, 32 is greater than 10. So the answer is yes. Okay. Now I have to find the p-value. So the p-value, again, we tested in the hypothesis test here. Remember, we found the p-value to be 0.1884. So that's your p-value for this test. And then you have to state your conclusion. And we said if the p-value is greater than alpha, we cannot reject the null hypothesis. If the p-value is high, the null must fly. Okay. So the p-value is 0.188. Alpha is 0.1. So 0.188 is greater than 0.1. So the null must fly. So you cannot reject the null hypothesis. No, Vince, so you do not reject the null hypothesis. Okay, so again, if you would like more details on this, please make sure to review week 4 and week 5 recordings. Okay, so do not reject the null hypothesis is the answer to this problem. Okay. Okay, now we go to this test. So it has been stated that the mean temperature of humans is 98.6. Suppose the researcher now claim that the mean temperature of human is less than 98.6. So the question here is, can you tell me, reading these two lines, what is the null and the alternative hypothesis? So first of all, what are we considering, the proportion or the mean? Should I use P or should I use mu? Mu. Very good. So I'm going to put mu here. So what is the null hypothesis? Mike has it correct. Very good, Mike. He says the null hypothesis is that mu equals 98.6. The alternative is that, see, they're saying suppose researchers now claim that the mean temperature of humans is less than, right? So I'm going to put less than here, less than 98.6. Okay. So that is your null and the alternative hypothesis. This is the test you're doing. Alpha is 0.01. You have a total of 700 observations and the sample mean is given as 97.5. So N is 700 and the sample mean, X bar, is given as 97.5. And so now you have to do this test. So let's just first do the test and then we'll answer the questions. Now, to do the test, again, as I said, the directions are given here, okay? So recall now we're again talking about the mean. Whenever you talk about the mean, you're going to access t-stats, okay? So always remember that. So now let's go to StatCrunch. So if I click stat, t-stats, we have one sample and we have the summary data, okay? And now we're going to enter the values that we found. By the way, we did miss one other value here. So as I was writing, the n is 700, sample mean is 97.5, and also we're given the sample standard deviation, which is S. Sample standard deviation is 0.7. It's given right here. Okay, so all this data is given to you. So I've written it in a nice, sort of like a tabular format here. Okay, and you should do the same. Make sure to write this because this will help you solve this problem. Okay, so we're gonna now go here. And what I'm gonna do is I'm gonna just simply take these values that I've written here and enter them in these boxes. So the sample mean is 97.5. Sample standard deviation is 0.7. Sample size was 700. And what do I need? So now I need to do the hypothesis test. So I'm gonna keep it here. But my null hypothesis is that mu is 98.6. That was my null hypothesis. And my alternative hypothesis, as you all said, was that is less than 98.6. Okay. So here's the test. The test is set up. Now we're going to hit compute. And I get my p-value to be less than 0.0001. So what do you think is the answer or the conclusion for this test? Should we reject or not reject the null hypothesis? Reject the null hypothesis. P-value is low, so the null must go. Okay, very good. Oh, I see there's a question. Oh, Donna, thank you for answering. Yeah, feel free to answer each other's questions. I'm actually kind of, I have dual screen here, but sometimes I might miss a question from you guys, but feel free to answer each other. Okay, and by the way, that is the correct answer, like Donna said. Okay, so now let's look at the problems here. The first part of the question was, what are the null and alternative hypotheses? So you all answered that correctly. What is the t-statistic? The t-stat is, so here's the p-value in the output given to you here, and here's the t-stat. The t-stat is negative 41.57. By the way, let me ask you guys, if I were to draw this, oops, bad drawing. But if you were to draw this, can someone tell me, looking at the hypotheses here, would this be a left tail test or a right tail test? Where would the tail be? Where would the rejection region be? Now think about it before you type, because this is from week 5. Most are saying left, and the left is the correct answer. Because as you all recall, I had said that the alternative hypothesis sort of points towards the tail. This thing is pointing towards where the tail is. Okay, just like Jeff says, yep. It's pointing that the tail is on the left side. So it's kind of like this. You have a line here beyond which you have the rejection region. This is the acceptance region. This is the rejection region. Okay. So clearly, here's my t-statistic, negative 41.576. And as you can see, because you rejected the null hypothesis, this 41.576 is going to be way down here somewhere. It's going to be in the rejection region somewhere because we rejected the null hypothesis. Okay, now what is the critical value for this test? So the critical value is where the rejection region starts, this value. How do we find that? Well, we know our alpha is 0.01. So because alpha is 0.01, the rejection region, the area is 0.01. And all I need to do is do the T, the critical T value. I'm going to call it TC, or yeah, TC, T critical. I need to find this TC value here. And the way to do that is very simple. I'm going to go to Stat, Calculators, and I'm going to access the T calculator. Okay. Here's the T calculator. Okay, and here's a question for you guys. My N is 700. That's the sample size. So what is my degrees of freedom DF? Can someone type the general form of DF? The full form. Yes, so it's N minus 1. So DF equals N minus 1. N is given as 700. So 700 minus 1 is 699. So I'm going to put 699 here. This should be pointing to the same direction as the alternative hypothesis, so it's to the left. And I am given the area, the alpha. Alpha is 0.01. So I'm going to put 0.01 here and hit compute. Okay. And the answer is going to show here. So here's the answer, minus 2.332. And look, the area highlighted matches the area that I said we're going to have on the left side. So this T critical came out to be negative 2.332. See that? And so if this is negative 2.332, then look at this T that we found from the hypothesis test, which I closed now, but it's right here. See, we found the T statistic, negative 41.576. So it's way down there. It's way off of, it's actually outside the screen, so far away, okay? Because this is the critical value and negative 41 is much less than negative 2.3. So it's way down there somewhere. So it's in the rejection region. Okay, you found the p-value, and the conclusion is do not reject the null hypothesis. Reject the null hypothesis. P-value is low, so the null must go. Now, the question also says use the table, and the table is very easy to use. Looking at alpha, we have 0.01, okay? So the first thing to do is look at 0.01 here. Okay, so this is 0.01. It's a one-tailed test, right? This is a one-tailed test. The tail is on the left side. So if it's a one-tailed test, I look at the exact alpha value here. If it's a two-tailed test, then you have to divide the tail, the alpha into two tails. So, but we don't have to worry about that in this problem. This is a one-tailed test, and as you saw, the tail is on the left side. And the tail area is 0.01. So locate 0.01 here. So I'm gonna take my cursor through this. Stop me when you see 0.01, okay? So here it is, 0.01. I'm looking for 0.01, 0.01, 0.01, stop. Yep, right there. This is 0.01. This is the column for 0.01. Okay, now let's select this column. And now I want my DF. I want to find my DF. Remember, my DF was 700 minus 1, 699. I need to find 699 here. So let's see. Looking at this column, let's see if we can find a row corresponding to 699. There's none. Okay, there's no 699. Why do you think there's no 699? What can we do here? What's the best thing to do? Yeah, Let's just find something that is closest to 699, okay? And the reason there is no 699 is because notice after, once you cross 50, or take a look at this. When you start at 0.01, the difference between DF1 and 2, look at these values. It goes from 31 to 6, and then it goes to 4.5. You see that the differences are a lot when the DF is small. But as the DF gets larger, the differences become very, very, very minor, right? In fact, look at the difference between 100 and 1000. See that? It's 2.364 versus 2.33. Not much of a difference for that many, right? For that much of a difference in DF. That's why after 100, they don't really show you other values because they're so close to each other anyway. But we're going to go to the closest DF that's given here to our 699, which I would say is 1000. Okay. So based on this, my critical value will be, looking at this column, scrolling down to 1000 row, 2.33. Okay. So this is the critical value 2.33. Now there's one trick here. The trick is that my tail is on the left side. It's not on the right side. These values are all given as positive values. So they're given as the values on the right tail. So we have to, in our minds, say that we have a left tail test. So I'm going to make this value negative automatically. So the answer will be negative 2.33. Okay. Now you see how cumbersome that was to do versus using the T calculator, right? The T calculator is so easy to use. All you do is type your DF, type your alpha, hit compute, and it gives you the answer here, right? And you see how the answer is actually pretty close to what you are getting. It's a little different because we have negative 2.33331, and here we have negative 2.33. So the difference is only in this one here, right? But remember that you did a approximation here. We selected the value DF equals 1000 really. We did not select 699. We just said that it's close enough. So this I would say is a much better answer. Okay. Yeah, you're going to use tstat. Well, both the answers are going to be accepted. They're so close to each other anyway. Okay, so we just did this problem. And if you can do this problem in StatCrunch, and by the way, I've given the directions here anyway, but if you can do this, you'll be just fine in the exam. Okay. When the question states less than in the statement. I'm not sure if I follow that question, but I think what you're saying is in this question you had to, so this goes to my lecture in week 5. Okay. In week 5, we practiced, reading the statements and building hypotheses out of them. So you have to read this statement, which says, the second part of the statement, which says, suppose researchers now claim that the mean temperature of humans is less than 98.6. So that is a claim, right? That's the alternate claim. The previous claim was that the mean temperature is 98.6, right? So the alternate claim is this. So that's why you choose the less than sign. Okay. But if, say, the researchers were claiming that the mean temperature of humans is greater than 98.6, right? Well, then you would have to choose the greater sign. Okay. No, you're not going to choose not equal, right? They're not saying not equal. They're specifically saying less than 98.6. So choosing that alternative hypothesis would be wrong then. Okay. So if the statement said, suppose researchers now claim that the mean temperature of humans is different than 98.6, okay, then it would mean that you would choose not equal. Okay. Vince, you're going to write the p-value as, for example, the one that we calculated, you're going to just write it as 0.0001. Okay. So the answer here, if you had to type this, In MyStatLab, in the exam or in any assignment, you would type this as 0.0001, okay, without the less than sign. Yes, then it's 0. That's just a matter of rounding. So if it says 3 decimal points, then this answer would round off to 0. Okay, good questions. Okay, so now we are going to confidence interval for difference in two proportions. So now you're given two proportions. This is week 6. Week 6 or week 5 and week 6. Okay, so starting in week 5, we started talking about this. So you have two proportions and you have to find the confidence interval for the difference between them. So let's read this problem. So consider a study in which there are two groups. Okay, there's an experimental group and then there's a control group. The experimental group includes subjects that receive a treatment, say a new vaccine. And so suppose 115 out of 716 subjects experience a side effect. So here you have an experimental group that received, in which you had 716 subjects. They were given a vaccine, a new vaccine, and out of the 716, 115 suffered a side effect. Okay. So the way I would do that is I would say you have the experimental group, and then I'm gonna, as we read this problem, there will be a control group. But the experimental group had x equal to 115 and n equals 716. And then the problem says the control group does not receive any treatment. Okay, so there's a control group. Obviously, when there's a new vaccine, they want to test it on some people. And then there's also a control group that receives an inactive form of that vaccine. Okay, so they can clearly see the difference. Okay, so there's a control group. In the control group, you have 623 subjects, okay, out of which 74 experience a side effect. Okay, so 74 out of 623. The question is, you have to find these p. This is the proportion, the first proportion, second proportion. You have to find these proportions and then find the confidence interval for the difference between them. So this is the problem statement. Okay, just to clarify, if they were stating that they were determining if something was less than something would hypothesis. Okay, so the alternative hypothesis is exactly what you read in the problem, right? Researchers are claiming that the mean temperature now is less than 98.6. So your alternative is simply just less than. If they had said researchers now claim that the mean temperature of humans is greater than 98.6, then your alternative hypothesis mean is greater than 98.6. However, if they had said, suppose that the researchers now claim that the mean temperature of humans is different than 98.6, okay, is not equal to 98.6. So then it would be not equal. Yes, the null hypothesis is always equal. So this goes back to week 4. I would say week 4 lecture would be very good for this review, of hypothesis testing. Week 4 and week 5, they would both be very good for the review there. But yes, the answer there is the null hypothesis you'll see everywhere is always equal sign. Okay, just like that. Because the null is based on a claim that was made in the past, right? So the claim made in the past is always an estimate, and you always have to say that that estimate is true under the null hypothesis. And then the alternative can claim either way, less than or greater than. Okay. Okay, so now that we have written our stats here, let's go construct this interval. And the construction is very easy. Here it is. because we are now dealing with proportions, so I'm going to go to stat, proportions. I have two samples now, right? You can see that there's an experimental group and a control group. So there are two samples. So I'm going to choose two sample, and I have the summary data. This is the summary data. So that's it. So I'm going to go here, go to StatCrunch. Let's go to stat, proportion stats, two sample with summary. Okay. And these I see I wrote them in a tabular form. I think you should do the same for the problems in your exam and the homework. Last homework, always write them in a tabular form because it's easy to sort of, you know, get the numbers from these problem statements. Once you have taken your numbers out, then it's really easy to think of how to solve the problem. The number of successes for experimental group, 115 out of 716. For the control group, 74 out of 623. I need the confidence interval. I don't want the hypothesis test. I need the confidence interval. So I'm going to click on this. And the problem set I need 99% confidence interval. So I want 99% here. And that's it. That is all. So you see how easy the problem was? Even though the problem statement made it look very long and complicated, once you have the numbers taken out from the problem, it's a very simple problem to solve. And you hit compute, and you get your lower limit and the upper limit. So the lower limit, and I'm going to put these in, say, 3 decimal places, is minus 0.007. The upper limit is 0.090. So this is my proportion limit, P1 minus P0. So in other words, what I'm saying is P1 minus P2. This is the lower limit for P1 minus P2, and P1 minus P2. This is the upper limit. And everything in between is accepted, okay? Is a believable value. So now tell me, what is interesting about this confidence interval? Very good. 0 is included here. See that? 0 is included in this confidence interval. So in other words, if the 0 is included, then you can have this situation, right? This is believable. Remember I said values in between the lower and the upper limit are believable. So obviously 0 is in between them, right? It's included in the interval. So 0 is believable. So if this is a believable statement, then I can say that P1 could equal P2, right? So if you were to do the hypothesis test, okay, then you would not be able to reject the null hypothesis, okay? Because P1 could equal P2, because 0 is included. The 0 is the key. But for this problem, all you had to do was find your lower and the upper limit. So the lower limit is given here, which is this answer, 3 decimal places. The upper limit is given here, okay? So the upper limit is this. Yes, that's right, Alfred. If 0 is not included, then you would reject the null hypothesis. But you can also check that doing the instead of calculating the confidence interval, you could also do the hypothesis test, right? But we didn't do that because the problem didn't require. Okay. By the way, this is at least for this problem, this is right at the edge. You see, if you consider 2 decimal places, this is right at that edge of being 0, right? Right at the edge of 0. So this may be a very close hypothesis test. But in any case, 0 is what you look for. Okay. Good. Okay, now this problem, I'm going to have you solve it with me. So Here are three graphs, and you have to match them with these, correlation coefficients. So first of all, how about this graph? Which value do you think it most represents? C. Very good. It's a perfect correlation, perfect positive correlation. So R is 1. Remember, what is the minimum and the maximum that the correlation value can be? Minimum and the maximum. -1 and 1. Very good. -1 is the lowest limit, and the -1 is the minimum correlation. Sorry, -1 is the value, is the minimum value that correlation can take, and +1 is the maximum value that a correlation can take. +1 means you have perfect positive correlation like this. As x increases, y increases. Negative correlation means -1. If this was -1, then the graph would go down in a straight line. Okay. 0 means there is no correlation. The data is scattered all over the place. Okay, how about this number 2? Which one do you think, between number 2 and 3, which one do you think are good answers? So for number 2 is A. Very good, because you see B has the lowest correlation value out of the 3, right? And so what that means is B should have the most variation in the data compared to the other 2. So B fits number 3 here. A fits number 2, and then C is the first one. Okay. So this is week, let me think. Week 6 is when we did correlation. Excellent. Okay, now here's a problem. Plot a scatter plot for this data and compute the correlation coefficient. What type of relationship exists? Okay, so the data is given here, and I've already entered the data here. Okay, so let me, this is question 11, so here's the data, x and y. So to do the plot, I'm just gonna go to graph, scatter plot, and a very simple is very simple. Choose x for x, y for y, and that's it. Just hit compute, and you get your graph. First of all, just looking at the graph, what do you think? Do you think I'm gonna get a positive correlation or a negative correlation? If I calculate the value, would it be positive or negative? It would be positive, yeah. Do you think it will be closer to 1 or closer to 0? It's not perfect, right? It's not +1 because there is some scatter, but would it be closer to 1 or closer to 0? It would be closer to 1, just like you were all saying. Very good. So let's calculate it. So I'm going to go into stat, summary stats, and correlation. That's how you calculate correlation coefficient. Choose your x and y both, and just hit compute, and take a look at that. Here's your answer, 0.966. Much closer, much closer to 1, right? And this signifies that there is a positive correlation. As x increases, y increases, and that's what we saw in the graph. Okay, so again, the directions are given here, how to do this, and the answer is here. So this was the graph, and it's 0.966. So you have a strong positive correlation between x and y. Okay, so this was a very simple problem, I think. Okay, now we go to probably the longest problem in this lecture. So now we have the same data set as this one. Okay, same data set, nothing has changed, but we have to do regression on this. So write the general form of regression. Okay, so the general form of regression is simply this given here. So recall it's y equals beta 1x plus beta naught, where beta 1 is the slope, beta naught is the intercept. So the way you remember this is beta 1 always is next to x, so it is the slope. Anything that's next to x is a slope. Okay, and then this is the y-intercept. That's your general form of the regression equation. And we're going to estimate beta 1 and beta 0. Okay, so the next is find the estimates. So we're going to do this for this data set. So how about I ask you guys, what do you think I have to do to find my regression equation here? So stat, calc, summary stats. Not summary stats. Very good. Stat, I'm going to go to regression. Okay, stat, regression. And then simple linear is what I'm looking for. Very good. Okay, my x again is the same data here as 11. And my y is this. And what did I say about this regression here? What did I tell you guys to always do? Save residuals, and what else? Save residuals versus x graph. Under the graph, you always save this residuals versus x values, okay? And then always save your residuals. And I hit compute, and you'll see that the residuals are here. It saved the residuals here for each value, and it gave me the output. So here's, well, there's a pattern, right? You can see that there's a pattern, a little bit of a pattern, but at least it's not a parabola pattern, but there definitely is a pattern there. But anyway, here's the output of the equation, the regression equation. So what are my estimates? What is the estimate for slope, first of all? What is the estimate for slope looking at this? 0.212. Very good. It's given right here. Slope estimate is 0.212. The intercept, what is the intercept? Given right there, 0.652. Excellent. And so because you now have the slope and intercept, you can form the equation yourself, right? But also the equation is given here. Y equals 0.652, which was your intercept, plus 0.212, which is your slope, times x. So the equation is given right here. Okay, and that's your answer to part B. Interpret the estimate of beta 1. So can someone do this interpretation for me? This is the equation. So what is the interpretation for beta 1, which is the slope? 0.212. Can someone do this interpretation for me? So I'll give you a hint. No, not that, not positive. There is an interpretation associated with it. So I'll give a hint. I think some of you are already typing, but the hint is if x increases by what, then y increases by what, right? That's the interpretation. See if someone gets this. Okay, Rob says if x increases by 1, y increases by 652. Okay, Rob, your interpretation is correct, but you got one of the numbers wrong. Not 0.652, but 0.212, right? Because that is the slope. So there's a guest who said it correctly. Whitney said it correctly. Very good. So the answer is if this x value increases by 1, then y will increase by this slope, by 0.212. Okay. So Mike put it in a nice way. If x goes up by 1, y goes up by 0.212. That's how you interpret the slope. Because the slope is the change in y depending on the change in x. Okay, now you have to compute the point estimate for sigma, the standard error. So point estimate for sigma, what is it? By the way, the answers are given here, okay? So I've written the estimates. And I've also written the interpretation. If x1 increases by 1 unit, then the response variable y increases by this. Okay, so everything is given there. So, okay, so what was the question? Compute the point estimate for sigma. So what is the point estimate for sigma? Let's see who gets this. We did this last week. Point estimate for sigma. No, that's not the sigma point estimate. We need the standard error estimate of the standard deviation is what we're looking for. Aha, Sal got it right. It's 0.194. Very good. It's given right here. See that? Estimate of error standard deviation. That's what we're looking for. That's the sigma that we're looking for. That's 0.194. Okay, so that's the answer to that. It's right in front of us. Yes. Okay, but now the question is compute the standard error for B1 for the slope. Standard error for B1 is given where? Standard error for the slope. Very good. It's right here. See that? Slope, standard error, 0.0252. Okay, that's the standard error for the slope. Okay, now you have to perform a test of hypothesis for the overall significance of the regression model. What is the null and the alternative hypothesis? So what is the null and the alternative hypothesis when you want to test that there is a relationship between x and y? What is the null hypothesis and what is the alternative hypothesis? Well, what is H? The question is, what is H? Yes, Vince is right. We're testing B1, right? We're basically testing if my test that I'm conducting is this. If y equals beta 1x plus beta naught, this is my regression equation, then to test whether there is a linear relation between the data, I have to test whether B1 is 0. And the alternative is that B1 is not equal to 0. Okay. Okay. Some of you have typed it correctly. Very good. So because if beta 1 is 0, then this becomes 0, and then y is just a straight line. Okay. Then there is no linear relationship. Under the null hypothesis, there is no linear relationship. But under the alternative hypothesis, there is a linear relationship. So that's the test I'm going to conduct. Okay. So it's given right here. Okay. So looking at the output, what is my conclusion for the test? Remember I said that that test is given here. So my p-value is 0.0004. So what is the conclusion based on some alpha, say 5% or 1%? Reject the null hypothesis. So if I reject the null hypothesis, then I will conclude that there is a linear relationship, right? There is a linear relationship because my beta 1 is not equal to 0. Okay, very good. So that was my p-value. So the p-value was 0.0004. The test statistic was 70.84. So the test statistic was given here, f-stat. Okay. So we reject the null hypothesis. So since p-value is less than alpha, reject the null hypothesis. The model is significant because beta 1 is not equal to 0. So the model can be used. So assuming that the residuals are normally distributed, okay, we're assuming that they're normally distributed, which, remember, I was looking at the graph and I was kind of saying maybe they're not, but let's just assume that they are. What is the average value of y if the value of x is 8? So if my x is 8, how do I calculate my y? Given that the model is significant, I can use the model. So how do I calculate that? This is the model here. Plug in 8 for x. Very good. Just put x here. Just put 8 here. So take your 8. So here it is. See that? Take your 8, value of 8, put it in this x, in place of x, and just calculate this expression. Just like Vince typed. Just calculate this expression and you get 2.348. Okay, so that is your predictive value of y. Okay, average of y when x is 8. Just put in 8 in this equation, find your y. That's all. And then you have to compute the 90% confidence interval for the slope of least square regression line. So for the slope, how do I find the confidence interval instead of these hypothesis tests? How do I find my confidence interval? Okay, Kimberly says edit. And choose confidence interval. Very good. Just choose the confidence interval instead of the hypothesis test. Choose this option, and my level has to be 90%. So I'm going to change this 95 to 90. Just hit compute. And there you go. The slope has a lower limit of 0.1612 and an upper limit of 0.2627. So what is interesting about this? What is interesting here? 0 is not included. So remember, 0 is not included for the slope. So that means the slope cannot be 0. And recall that that is what we concluded under the hypothesis test. We said that beta 1 cannot be equal to 0. We rejected that, right? So we conclude the same finding under the slope. 0, basically the slope cannot be 0. Okay. See, you guys know this. Very good. Okay, we're on to the last problem. So here's a data set given to you, x1, x2, and y. Okay. The first question is, what is the multiple regression equation? And the second question is, interpret the coefficient for x1. So how do I find the multiple regression equation? Given that my data is here, this is my data. Okay, Whitney says stat regression, and then multiple. Very good. I'm gonna go to multiple linear. Excellent. I'm gonna go there. Okay, and then I just choose my y for problem 13, and choose my x, the two x variables for problem 13, x1 and x2. Okay, so I choose those two variables, just hit compute, and here it is. Okay, here's my intercept, y-intercept 3.607. Here's the slope for x1. Here's the slope for x2. And the equation, if you want to type the equation, it's given here as well. Okay, so you can see x1 has a slope of 0.116 here, which is the same here. x2 has a slope of negative 0.100, which is the same slope here, and here's the intercept. Okay, so this is a very, very, very simple problem, you know, as it is given. And so once you type it, it's going to look like this. Okay. Yeah, so there was a, I think someone pointed that out yesterday. This is a, thanks for pointing that out again. This is a big, big typo, huge typo. This should be Y. This is wrong. This should be Y. Okay. This should be basically this guy, Q13 underscore Y. Okay. Does it matter which order since that is in a different order? I'm not sure if I follow that question. What is the question again? Does it matter? Oh, you mean the order of this? No, that doesn't matter. You can write it in any way. In any way. You can write this first, then that, then this. This doesn't. Because it's a simple expression, right? You can write the expression in any way, but you have to write the slopes for the correct variable. So x1 must get this slope, right? Because that is what the answer is. So you can't just use this slope with x1, right? Because that would be wrong. But you can rearrange it in any way you like. So like I write my variables first, and then I write my y-intercept. Okay, so that's the answer there. Okay, now we have to do the interpretation for x1. So x1 has a slope of 0.1163. Okay, so that's my slope. So what is the interpretation there? Pretty much the same as the previous problem, except you have to add one line, and you can see that here. Well, it's very simple. The interpretation is if x1 increases by 1, then y, or the response variable, increases by this slope 0.1163 only if you keep x2 constant, okay, while holding x2 constant. That is the only line you have to add when you do interpretation for multiple regression. Okay, so in the previous problem, it was very simple. If x increases by this, y increases by this. But in this problem, because there are two x variables, so you have to say that if x1 increases by 1, then y increases by 0.1163, given that x2 is held constant. Okay, and that is that. And that's it. That's the end of the review. And so you can see that you have done all these problems, and I felt that you all sort of you almost knew how to do this in StatCrunch, which is very good. So it's only a matter of practice, some practice, and I'm sure you guys will be fine. Well, I think you're probably finding that because, Sandra, because if you have done the exam, then obviously this is gonna look easier. But if you think this is easier, I'm pretty sure you will be doing great in the final exam because these are not easy problems. So, yes, I will be by the way, I will be posting the recording in about 10-15 minutes. Okay, so it'll be available very, very soon. Yes, so the problems will be just like these, what we covered. This basically covers, I think, 75-80% of the final. They're not going to be exactly the same problems, I can tell you that, but they will be similar. Okay, great. Well, we have at least one more webinar on Thursday. If needed, we will have a second one, but I think we should be fine on Thursday. I think we're gonna finish on Thursday. So yes, Conrad, that is right. So If you want to do, there's no time limit on the final, no. If you want to do the second attempt, you have to do all 28 problems, and then the higher score counts. Kimberly, they're very, very similar. That's all. I think that's all I can say. They're very similar to the problems in the homework. Nope, you can take it in multiple sittings. I think somebody mentioned earlier that you just have to close the exam without hitting submit, and then you can resume later. That is due next Tuesday, I believe. Please make sure to look into your courses in the in Modulate folder. It should tell you when it's due. Actually, the final exam should tell you when it's due in MyStatLab. Yes, the webinar on Thursdays for Modulate. Yeah, it's due next Tuesday. That's what I thought. Vince, the study guide, as I mentioned, is available on Professor David's website. So it's here, list and tips and review problems. But also this should be posted in your courses in the discussion forum. And if it's not posted, I encourage you all to go ask your instructor to post it because then other students may not have seen it. Yes, Sandra. So you can go back to the assignments that, on the problems you missed. You can resubmit them. The maximum you can get is 90% on those problems. There's a 10% penalty, but still you can get up to 90% credit on the problems you missed. So that will definitely raise your grade. Okay, so we'll meet on Thursday, 9 p.m. and good luck with the final. Module 8 is not covered in the final exam, so that's good. All right, so I'll see you guys on Thursday. I'm gonna stop the recording.